In this video, we're going to be looking at percent yield. Now, previously I mentioned how mapping, it may not always seem like it's necessary, especially with a simple one-step calculation. But I said that we're really going to start ramping up and it would become necessary really for you to be able to manage everything in a complicated process. Well, here's an example. So again, we're going to use the synthesis of water from hydrogen and oxygen. If we react 3.03 grams of hydrogen with excess oxygen and we get 24.9 grams of water, what is the percent yield for the reaction? Well, I know if I start off with a certain amount of hydrogen, I'm probably going to be converting it to moles. And I also know that we'll be going over to moles of water. Now, previously we would just go straight up to our grams and that would be it. In this case, we're going to do that, but we're going to go to what's called a theoretical yield. And so I'm going to box this and call it grams T, meaning theoretical. This is the absolute maximum amount of water we could get if everything runs perfectly. But our actual yield is 24.9 grams. This is what we actually got as opposed to what we could get, which is actually what we've calculated in the past. And what I need to do from here is write that we're going to multiply this by 100%, and that equals our percent yield. All right. So ultimately, we're trying to get here. But the first thing we need to do is we need to say, all right, I've got 3.03 grams of hydrogen. What is the maximum amount of water I could have got if everything had gone perfectly? And then I just need to compare, okay, what did I actually get divided by what I could have got, make that into a percentage, and that's our percent yield. So I'm going to go run through all of the conversion factors. We've got hydrogen, H2 is 2 times 1.01 is 2.02 grams per mole. I know with water, it's going to be 2 hydrogens again, so that's 2 times 1.01, but I also have 16.00, and together that gives me 18.02 grams per mole of water. I also know that I've got a 2-to-2 ratio from this 2 and this 2, so my mole ratio is going to be a 2-to-2. Now, where's my starting point? 3.03 grams of H2 times, I need 3 conversion factors, and I'm ultimately going to get to grams of H2O, and that again is going to be my theoretical yield. So this looks exactly like we've done before. I have times 1 mole H2 over 2.02 grams of H2. I have times 2 moles of H2O over 2 moles of H2. And I have 18.02 grams of H2O for every 1 mole of H2O. Cancel, 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 and cancel. And what I end up with is 3.03 times 1 over 2.02 times 2 over 2 times 18.02. We have 1.5 moles of water, which is going to be 27.03 grams. 27.03 grams. And that is our theoretical yield. So I'm going to put that here. 27.03 grams is our theoretical yield. Now, if I have 24.9 grams and I divide it by 27.03 and multiply it by 100%, that is what gives us our our percent yield. And that is going to be 92.1%. I do want to point out that since we have 3 sig figs here and 3 sig figs here, we have to have 3 sig figs as our percent yield. But that is how you would calculate the percent yield for this particular problem. Now, that is one type of percent yield problem that one could face, But there are other possibilities. For example, here we're given the percent yield, and we're asked actually how much water can you actually expect to get. Say you've done this reaction 1,000 times, and you know that you've got a certain amount of hydrogen, but you know you're not going to get as much water as you theoretically could. Well, you know that you're only getting 92% just because that usually happens. So what should you actually expect your actual yield to be? In this case, we're going to basically do the same thing. We're going to say that we start with 3.03 grams. We go to moles. We go over here to moles of water. And now we still need to go up to theoretical, grams of theoretical yield. But here, my grams of actual yield, that's what I'm looking for. It says how much water can you expect to get actually. Well, in this case, I'm going to say times 100% equals 92%. Sorry, 92.0%, so we have 3 sig figs. Notice this is the same exact problem as I had before with a different variable, but even the numbers are going to work out the same. In this case, I would have to go through the same process. I would get to the same theoretical yield of 27.03 grams. 27.03 grams. And in this case, I'd have to rearrange this a little bit because I still don't know what this x is. But rather than showing you how to get to the 27, since we just did that, I'm just going to focus on what we have here. And I'm going to say that our x grams of actual yield over our 27.03 grams of theoretical yield times 100% equals 92.0%. If I multiply both sides by the 27.03 grams, I divide by the 100%, I'm going to get that x grams of actual yield is equal to 24.9 grams of H2O. Which should probably be familiar because that's exactly what we had as our actual yield in the previous problem. It's just that in the previous problem, we didn't have to calculate actual yield. We had to calculate the percent yield. Moving on. Another way of looking at percent yield problems is this. So what we're doing is we're saying we need to get 36.04 grams of water. But if we aim to use the amounts of hydrogen and oxygen that would give us exactly that on a perfect day, we know that we're going to undershoot it because every single time we do this reaction, we only get 92% yield. So what we need to do is we need to give a little bit more hydrogen and oxygen in order to make this reaction produce the amount of water that we want. So in this case, what we're going to say is that our 36.04 grams is our actual yield. And, well, we have to say that we're going to multiply this by 100% and get 92.0%. We have to have a theoretical yield not given to us. So we're going to have that. And ultimately, we're trying to get back to the mass of H2. So I need to actually get back here, which means that I need to have the moles of H2, which means that I need moles of H2O, and I need the grams of theoretical yield that would get me ultimately back to this mass of hydrogen. So in order to solve this, the first thing I need to do is take this section and essentially use it to solve it like an algebra problem to get to my grams of theoretical yield. And if I do that separately, I'm just going to rearrange this so that we have, I'm going to get rid of the percents. I'm going to say that we have 36.04 grams of actual yield is equal to our grams of theoretical yield times 0.920. And if I divide both sides, then what I'm going to end up with is, let's see, I'm going to end up with 39.2 grams is equal to our theoretical yield. So I need to write 39.2 grams. And if you look at it, 36 grams over 39, it's about 92%. So I need to go from our grams of theoretical yield of water back to our grams of hydrogen. In this case, I can say we have 18.02 grams per mole, a 2-to-2 molar ratio, and 2.02 grams per mole over here. So I just start with my 39.2 grams of H2O times 1 mole of H2O for every 18.02 grams of H2O times 2 moles of H2 for every 2 moles H2O times 2.02 grams of H2 for every 1 mole of H2 equals grams of H2. I know this because my grams of water, moles of water, moles of water, moles of hydrogen cancel out. My last unit standing on the left is grams of H2. My last on the right is the only one on the right. It's also grams of H2, so I know this works. The answer is going to come out to 4.39 grams of hydrogen. That does have the right number of sig figs. It's 3. Yes, I've got 4 sig figs here, but I'm limited by the 3 here. Something also that could be useful to you, just keeping track of sig figs, is that, in a long problem like this, you might just not be thinking about sig figs all the time. So perhaps when you read the problem, you might consider writing in the corner 3SF and circling it. And that way it's like a nice reminder, especially if you're going to do a problem out here, and then by the end of it, oh yeah, I forgot 3 sig figs. It's a good way to keep track of it, so that's something that you might consider doing. Anyway, these are 3 different ways of looking at theoretical and actual yield and percent yield, and I hope that's been useful for you. Let me know what you think of it, and give feedback if you can. Thank you.